Hello Year 12, and here we are with another video here for the normal distribution. What do we mean by normal distribution? This sort of bell shape. This curve here, where this is our score, and on a vertical axis here, this sort of invisible vertical axis here, that would be a frequency. Right, it tells us that close to the mean, the frequency is the highest. Okay, so the mode is the same as the mean, is the same as the median on a normal distribution curve like this. Okay, this is quite a common distribution for sort of natural phenomena and such. So, what we need to learn about this thing is that within one standard deviation either side of the mean, right, we can calculate standard deviation, we sort of know what that is. One standard deviation either side of the mean, that will contain 68% of all scores. Okay, 2/3, or close enough, of all scores will be within one standard deviation either side of the mean. Right, and that's a good thing to sort of remember vaguely when we talk about, if you're given figures like the mean and standard deviation of a data set. What does it mean? Well, you can sort of think that most scores, more than half of scores, about 2/3 of scores, will be within one standard deviation of the mean. If I stretch it out to 2 standard deviations of the mean, I don't expect to get all of the scores, but I do expect to get 95% of them. Okay, that's 19 out of 20 scores typically would be within 2 standard deviations below and 2 standard deviations above the mean. Altogether, that's 4 standard deviations from the very bottom here to the very top here. Within that range of 4 standard deviations, I expect to collect 95% of all scores. If I go out to 3 standard deviations below and above, that would be 99.7% of all scores typically. Only 3 out of every 1,000 scores I would expect to be outside of that range. That would be quite unusual, right? To be more than 3 standard deviations above or below the mean. That would be quite unusual. Now, those are the figures, 68, 95, 99, 7 that you get in the formula sheet. You can interpret those to draw up this diagram here. You don't get this diagram in the formula sheet, and this is the helpful one, I think. Okay, that within each of those bands, right, we know that there's 34% in this band, 13.5% in this band, 2.35% in this band, and 0.15% everything above there. Right, and it's symmetrical. We get the same on the left there. Now, I will strongly suggest that you memorize this diagram here and that you sketch it up right quickly when you have these questions, and that's what we're going to do when we look at a question. So, that's a mess. Did that happen? Okay, so let's have a look. My notes have gone all over the shop here. I don't know what OneNote's doing, but anyway, your printout one should be fine. So let's have a look. The heights of a large group of adults are normally distributed, right? See this thing, normally distributed? That means, right, that I can put them on the curve. A mean of 170 and standard deviation of 8. Right, let's do this. Right, my curve is going to look a bit like this. There's my mean, which is at 170. Right, I expect plus 1 standard deviation is going to be 178. And down here, 162. Right, that's 1 standard deviation either side. Here, right, if I go to 2 standard deviations either side, this is going to now be 186 or 154. If I go out 3 standard deviations, then I'm up to 194 up here, and down here 146. Rightio? Got those. I know that this is 34%. This is 13.5%. This is 2.35% of scores, and 0.15% of all scores, and the same on the left there as well. Okay. I suggest that you sketch that up whenever you need these. So what percentage of heights lie between 162, that's here, and 178 is here? So that's a 34 and another 34. 34% plus 34% equals 68% of all scores. Righto, we didn't need the diagram to do that. It's very much by definition there, but nonetheless, we've got the diagram to use that. 68% of all scores lie between 162 and 178. What percent are more than 178? So that would be from here onwards, 13.5 plus 2.35% plus 0.15%. And what does that equal? I think that equals 16%. 16% of all scores I expect to be more than 178. All good? Oh, again. Needs to be a plus. Okay, let's try if I can scroll now. Oh, yeah. Sorry, something weird is happening. Now, let's have a look. If a random sample contains 6,000 adults, how many have a height between 146 and 194? Okay, 146 and 194. That will be all the way down here to all the way up here. Now, that's going to be, we can add these up, 0.235, whatever. But that is actually our 99.7. If I add those together, it's 99.7% of the 6,000. What does that equal? Well, that's 3 out of every 1,000 are not included in that. So that's going to be 6,000 minus 18 people is 5,982 people. Now, slightly trickier here between 162 and 186. Right, I'm going to make sure I don't draw on the picture again. 162, that's from here, from 162 to 186. So that's a 34, a 34, and a 13.5. 34% plus 34% plus 13.5% equals 81.5%. Right, so it's going to be 81.5% of the 6,000. So 0.815 times 6,000. Struggle to do this in my head, but I reckon it's about 4,890. Yep, there we go. So that's how we apply the normal distribution to questions like this to either work out the percentage of people within a band, or to work out how many of a given sample are going to fall within a certain range of scores. Rightio, hope you enjoyed it. See you next time.